I'm live. All right, lesson 18. Going to factor some more. Intermediate level. This is jumping it up just a little bit. We're going to do what I call trinomials. So again, what you're looking at on the screen right now, that's the guided notes. There's a link right down there that you can print these out. It's a nice PDF file. You can print them out and take your notes on them. There's also a homework down there too. Link to the homework. This is what's due in the D2L Dropbox. I think it's 2 pages again, right? 1, 2, yeah, not so bad. And now let's, with no further ado, let's get to the lecture. So here we are, lesson 18, intermediate factoring. So let's see, last time, one of the things we were doing in lesson 17 was we were undistributing, you might remember. Well, today we're going to unfoil. We're going to unfoil. This is your approach to trinomials. What's a trinomial? That's a trinomial. It's got 1, 2, 3 terms in it. Generally, not always, but generally it's an x squared and then an x and then a number. That's very common trinomial. And you factor trinomials by unfoiling. So before we unfoil, let's foil again. So this example here, we're going to foil again. Remember, when you got 2 parentheses like this, you basically take this x times this x, and you get an x squared, right? That's called the multiplying the first 2 terms together. And then you multiply the x times the plus 6 here to get a plus 6x. You could say we just multiplied the outside terms together. And then the minus 2 times the x, which you could say is multiplying the inner terms together. And then the negative 2 times the positive 6 makes a minus 12, which is basically adding, multiplying the last terms together. So this is where the word foil comes from. And then, of course, what happens quite often is that these 2 terms in the middle, the outer and the inner products, are like terms. They're both x terms. Like terms can be combined, so you combine them. And so you end up with x squared plus 6 minus 2 is plus 4x, and then the minus 12 at the end. That's how foiling went. Now look at this example over here. Maybe I'll zoom in on it. Well, maybe I won't zoom in yet. So we get this x squared plus 4x minus 12, and we want to go the other way. We don't want to foil out and get this. We want to unfoil. Actually, I hope this looks extremely familiar because we foiled this, x minus 2 times x plus 6. We foiled this, and we got that answer. And notice over here, we're starting with that answer, but this time we want to go the other way. We want to somehow end up with this. Somehow we want to unfoil that and end up with x minus 2, x plus 6. So let's see, how would we do this? The first thing you would do is you would just say, look, I recognize 3 terms. It is a trinomial. I'm going to try to unfoil. I'm not guaranteeing it always works, but I'm going to try to unfoil. So I'm going to put some parentheses down here. Just open it up. And then what you got to do, well, let's look back at this thing. How did we get the x squared? We got the x squared by multiplying the x times the x here. How do we get this x squared? I'll bet you it's going to be by multiplying the x times the x here. In other words, the x squared came from multiplying the 2 first positions, x times x like that. Now, look at the 12. Where'd we get the 12? We got the 12 by multiplying the 2 times the 6. So what I'm going to do then is I'm going to put the 2 here and the 6 here. Now actually what I did was I got a minus 12 by multiplying a minus 2 times a plus 6. So the signs are kind of important to consider when you're doing this stuff. So really, we got a minus 2 times a plus 6 gives me a minus 12. So notice that when you go to foil this out, you'll have your x squared. Yep. And then you'll have, oops. Whoops. Come on, guys, with the whoops. There. Make that fixed. Good, 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 good. Okay, and then you'll have the x times the plus 6x, giving you a plus 6x on the outside. And then you'll have a minus 2 times x, giving you a minus 2x on the inside. And what makes this what makes this work, I should say, is that this plus 6x and this minus 2x, your outer and your inner term products here, when you add plus 6x and minus 2x together, you do indeed get the plus 4x. And then, of course, the negative 2 times the 6 has given us the negative 12, which is the last position. So it works just great. Get some of this stuff out of here. Okay, clean this up just a little bit. Let's put that back. Okay, cool. Now here's the question you might have. You'd say, okay, that worked. So you put the x's here and here. That makes sense. And then the negative 12 you break up as negative 2 times 6, and it worked. But how did you know that you had to use a negative 2 times a 6? Is that the only way that you can make a negative 12? Well, no, of course not. You can make a negative 12 all kinds of ways. Like, why not try something like this? X minus 3 times x plus 4. Because negative 3 times 4 is a negative 12, and that's what we want. So won't that work? And the answer is no, it won't work. And I'll prove to you that it doesn't work. Prove it to you right now. Because yes, x times x will give me the x squared. But if I go x times 4 like this, I'll be getting a plus 4x. And if I go minus 3 times x here, I'll be getting a minus 3x. That's my outer product and my inner product. And then these two things, plus 4x and minus 3x, those don't give me the plus 4x that I need right here. Right? If I were to add those together, if I were to add a plus 4x and a minus 3x together, that would give me a plus 1x. And that's not what I want. I don't want a plus 1x, I want a plus 4x. So that's why it doesn't work. It doesn't work. You don't do it that way. So what happens if you innocently tried negative 3 and 4 yourself, because you said, hey, I need negative 12. I'll just do negative 3 times 4. Well, what you do is you set it up. You set it up just like we set it up here. Good colors. You set it up just like we set it up here, and then you have to do this checking of the products. You have to check that this outside product, x times 4, gives you the 4x, and this inner product, negative 3 times x, which gives you the negative 3x, you have to check, does the plus 4x and the minus 3x, does that give me the plus 4x? No, it doesn't. And because it doesn't, I'm just not going to do it that way. So I'm erasing some of this stuff. I'm actually going to erase that whole thing. It's no good, right? It's no good. It's no good. It's on your notes, but it's no good. So there's a little bit of trial and error involved is what I'm getting at here. But let's go through this again. Maybe we can go through this a little more quickly this time. So I'm looking at 3 terms. It's a trinomial. So I'm going to try to unfoil question mark, because it's not guaranteed to work. But again, you make a couple parentheses like this. You kind of want to put 2 terms in here and 2 terms in there. Now to get the x squared, you want to be multiplying x times x in the first positions. And then, this is the important part. To get the 12, you want to be multiplying something, maybe 3 times 4. You want to be multiplying something in the last positions. It could be 3 times 4, it could be 2 times 6, it could be 1 times 12, it could be flip, sometimes you swap them around the other way, and so on. There's lots of possibilities to try. And so you just keep trying them until you get something that works, hopefully. If nothing works, it can't be done. But you're hoping that you'll find something pretty soon that'll work. So does the 3 and the 4 here work? Well, you have to be thinking in terms of, on the outside, I'd have an x times a 4 is a 4x. And on the inside, I'd have a 3 times an x is a 3x. And then here's the magic question. Let's use a better color. here's the magic question, or the big question. Does this 4x and this 3x add up in some way to give me, careful now, negative 7x? Now you're adding these things, right? You want to add those things and get a negative 7x. Well, it would work pretty great if you just had negatives that you were adding up. If you were adding a negative 4x and a negative 3x, that would work. So if you want this to be a negative 4x, that means putting a negative over here. So that again, x times negative 4 would be negative 4x. And then you'd want to have a negative here too. So that negative 3 times x would give me the negative 3x. And then the negative 4x and the negative 3x does indeed give me the negative 7x that I want. And then just double check real quick. Does a negative, let's do it this way, does a negative 3 times a negative 4 give me a positive 12? And the answer is luckily yes. So you do have to make sure all the signs are working out. So negative 3 times negative 4 is indeed positive 12. We do have the negative 7x in the middle. We're done. And that's our answer. You want to write it nice and official? I'm going to write it nice and official. I'm going to go like this. X minus 3, x minus 4. Answer. How's that? That looks good. So I'm calling these, by the way, I'm calling these the friendly trinomials because, yeah, I'm drawing them out. I'm making myself take a long time to explain the little pieces of it. But really, once you get used to these, you're going to get fast at these. What makes them nice, by the way, is the fact that this first term here is just an x squared. Nice, and it's positive and everything. It's just an x squared. Beautiful. When the first term is an x squared, you should smile because it's a happy trinomial, friendly trinomial. So, okay, trinomial, let's try to unfoil. I'm going to think of the x squared as an x times an x. Right? That seems to be the way these always work. X squared is x times x. Now I have to think about the 12. 12 breaks up a couple different ways, so you just have to start trying them. So if you try a 1 and a 12 like this, okay, the way you see if it works is you look at the outside product, 12x, and then you look at the inside product, 1x, and then you ask yourself, you ask, can I add together some kind of a 12x and a 1x to get that, a negative 1x? And the answer is no. Even if you made this like a minus 12 and a plus 1 or a plus 12 and a minus, there's no way you're going to add up to minus 1. So that does not work. So what I'm doing is I'm backing up and I'm saying 1 times 12, don't cut the mustard. So I have to try something else then. How about if I try 2 times 6? By the way, I like to be methodical a lot. So I tried the 1 and the 12, and the next thing I'm going to try is a 2 and a 6. And if that doesn't work, the next thing I'll try is a 3 and a 4. I like to think in terms of dividing 12 by everything I can, a 1, a 2, a 3, and so on. And then I'll just try everything. So let's see if the 2 and the 6 is going to work for me. Well, if I do, my outer product is a 6x, and my inner product is a 2x, and I try to combine a 6 and a 2, whether by adding or subtracting, because one can be plus, one can be minus, it's still not going to get a negative 1x. I mean, that's like a negative 1x. That's no good. So, okay, that didn't work either. I guess I'm not going to play with this, the 2 and the 6. Come on, you, back up. So it must, if anything's going to work, it must be the 3 and the 4, I guess. Tell you what, let's just go like this. Boom, boom. So again, I'm going to try the 3 and the 4. So I'll put the 3 here, I'll put the 4 here. Again, what matters is the outer and the inner products. So the outside product is a 4 times an x. Could be plus, could be minus, depends how I set up the signs. The inside product is a 3 times an x. Now I want to look at this 4x and 3x and say, okay, can I somehow get a minus 1x out of them? Here's how you get a minus 1x out of them. You make that a minus 4x so that when you add a plus 3x, you'll get the minus 1x. So that's the ticket. So I want to have this be a negative 4x, means I want to put a negative there. Maybe I'll make it an official blue negative. And I want this to be a plus 3x, so I'm going to put a plus 3 there. And then you do have to double check real quick. You got to make sure that this is also working. You got to say, well, if I do a positive 3 times a negative 4, do I get a negative 12? And the answer is yes. It really does work. Everything's working. So here's my answer right there. X plus 3, x minus 4. So you practice these things, you start to get used to them after a while. You start to get pretty quick. All right. Now for the, I'm not going to say they're unfriendly. They're not as friendly. We'll just call them the not unfriendly trinomials. These aren't so bad. These aren't so bad. Thing is, they're not quite as good. Why aren't they quite as good? Because we don't just start with x squared. We start with 2x squared. So that means that if I'm going to try to unfoil, I can't just put x times x. I'm going to have to put 2x times x, which is going to make it a little more complicated when I go to, do my outers and inners again. So next up, let's do the 1. The 1, remember the 2x squared goes into the first positions. The 1 goes into the last positions. Well, actually a 1, there's only one thing you can do with 1s, and that's to put 1s in there, right? So actually this is not going to take too long, I guess. It has to be 1 times 1. Now we just got to make sure we can get it to work. So I go 2x times 1 will be a 2x on the outside product. 1x is a 1x on the inside product. Now the question is whether I can combine, by adding or subtracting, combine 2x and x to get 3x. Oh, sure I can. I'll just add the darn things. So I'll make this a plus 2x and a plus 1x. So if this is a plus 2x, then this will have to be a plus 1 here. And if this is a plus 1x, this will have to be a plus 1 here, right? Because then plus 1 times x is plus 1x, and plus 2 times 1 is plus 2x. So that's working pretty good. So actually I'm done. Hey, that wasn't so bad, was it? It's not unfriendly. It's not unfriendly. But again, it's a little more work because your inner and outer products, I don't know. It takes a little more work, it seems to me. Here's another one where we've got, again, we're not starting with just x squared. We got a 3x squared. So the main difference is that when you go to unfoil, you can't just put x and x. You have to put 3x and x. Okay, that's not so bad, really. Now the 2, I guess there's only really one way to do it too, or is there one way? Yeah, there's kind of 2 ways. You could either do 1 and a 2, or you could switch the 2 and the 1 around. So if I go the 1 here and the 2 here, let's just see if it works. So my outer product would be a 6x. 3x times 2 is 6x. My inner product would be a 1x. Can you combine a 6x with an x to get an x? No, you cannot. That ain't it. That's not going to work. That's no good. So the 1 and the 2 didn't work that way. So I'm going to have to try the other way. Put the 2 there and the 1 there. Let's see if that works. Hopefully it will. So now my outer product is going to be 3x times 1 is 3x. My inner product is going to be 2 times x. And the question of the day, can I combine a 3x and a 2x to get a 1x? I can if I do it this way. A positive 3x with a minus 2x. You always want to think in terms of adding, adding positives and negatives together. So a plus 3 and a minus 2 gives you a plus 1. So that's what we want. And then you can back up and say, okay, so if I want this to be a plus 3x, that means I have to be multiplying a 3x times a plus 1. And if I want this to be a minus 2x, then I'm going to want this to be a minus 2 times an x, right? Minus 2 times x gives me the minus 2x. Whoops, put the minus back in there. Okay, good. Spot check, always spot check. Make sure it's really working all the way through. So I know that the 3x times the x is giving me the 3x squared. I know that's working. I just checked the outers and inners. But check this too. Negative 2 times 1, yep, it's negative 2. It works. So it's all working great. Boink, 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 boink. There's our answer right there. Here we go. That looks good. Not unfriendly, anyway. Again, the key difference is that the first term is not just x squared, it's something else. In this case, it's 2x squared. So again, you know that when you unfoil, you're going to have to put a 2x times an x. Now the 12 is a little more involved than we've had so far. It could be a 1 times a 12, or a 2 times a 6, or a 3 times a 4. Or you could switch them around and do 4 times 3, 6 times 2, 12 times 1. If you want, you can just kind of, list them all out over here. And then as you try them, if they don't work, you can cross them off. Some people like to be very methodical like this. So maybe we'll try methodical this time. Try the 1 and the 12. 1, 12. What we're looking for is whether the outer and inner products could possibly work. 2x times 12 is a 24x. 1 times x is a 1x. Is there any way on the planet that we could do a 24x and add a 1x somehow to get a 5? There's no way on the planet. It doesn't work, even with an expensive calculator. It will not work. And so what that means is that I can actually cross this off. I know it's not going to work. Let's try the 2 and the 6 now. Boink, boink, boink. Let's try the 2 and the 6. So I put a 2 here and a 6 here, and I see what happens. Outside, I'm going to have a 2x times 6 is 12x. Inside, I'm going to have a 2x. Question. 12 and 2, does that make a 5? No way. You can add them, you can subtract them. No way. Not going to work. So forget that. Might be faster if I just use the eraser tool. Huh? Okay, 2 and 6 didn't work. How about 3 and 4? Let's try it. Outer product's going to be an 8x. Inner product's going to be a 3x. Question. 8x and 3x. Will that make a 5x? Hey, it might. It might now. It might. Remember, we want to add them together, and one of these might be plus, one of these might be minus. So we got an 8x and a minus 3x. If I had a positive 8x and a minus 3x, that would give me the plus 5x. If I want to have a plus 8x, that would have to be a plus 4. And if I want to get a minus 3x, this will have to be a minus 3. Again, before you congratulate yourself and go home, you have to really just double check. I've got a negative 3 multiplying a negative 4 to give me a negative 12. Always check your last terms. Make sure the signs are working. And they are, so we're good. We're happy. We got it. We got it. There she blows. Oh, that looks ugly. There she blows. Now what do we got here? Well, again, it's not x squared, so you know it's not friendly, but it's a 3x squared, so that's not so bad. The reason I say it's not so bad is because there's only one way to break up 3x squared. 3x times x. So at least that part you know, right? The 3x squared, there's not too many things to try there. Now with the 20, I could be looking at a 1 times a 20, a 2 times a 10, a 4 times a 5, or I could be looking in the opposite direction, like this, right? So those are all of my possibilities. Whoops, come on you. These are all my possibilities that I can try. The reason it might be good to list them all out, by the way, is because sometimes if you're just guessing, if you're just making guesses like, I'm going to try 4 times 5, I'm going to try 2 times 10, whatever. If you guess like that, you might get to the answer quicker. But on the other hand, you might get stuck sometimes where it's like, well, that didn't work. Should I try something else? That didn't work. And you can lose track of what you've tried already and what you haven't tried already. So sometimes it's nice to make a list and then just kind of be methodical about it. Now, having made the list doesn't mean you have to start at the top of the list. Maybe I'll start in the middle of the list. I don't know. I want to start with the 5 and the 4. Let's see if this does me any good. Starting with the 5 and the 4, I would have a 12x on the outside. I would have a 5x on the inside. Does a 12, come on you. Does a 12 and a 5 give me a 19? No, it does not. Boink, boink, boink. So I'm not going to do that then. Not the 12x, not the 5x, not the 5, not the 4. And now I can cross off. Not the 5, not the 4. What if I did it the other way? The 4 there and the 5 there. Well, the 3x times the 5 would give me a 15x, and the 4 times the x would give me a 4x. So the question now is, can I combine a 15x and a 4x to get a negative 19x? And I think we're on to something here, folks. This may work. Again, don't get too excited. Sometimes you think it's going to work and it doesn't. You have to be very careful and check it all the way through. But I'm thinking negative 15x and negative 4x, that'll give me the negative 19x that I want. So again, if I want 3x times this to give me negative 15x, then that has to be a negative. And if I want this to be a negative 4x, that has to be a negative. And now, just to be really careful, check your last products. You know that 3x times x is 3x squared. We know that's going to work. The real question, will negative 4 times negative 5 give me a plus 20? Plus 20, and it does. See, when you put these signs here, you have to make sure that this sign's also coming out okay, right? Because sometimes it won't. Well, 8 down, 4 to go. What makes these different? Well, what makes these different is, first of all, that's not just x squared. But second of all, there's more than one way to break up 6x squared. See, up here, these weren't so bad because 2x squared, ooh, that looks terrible. 2x squared, it had to be 2x times x. There wasn't too much guessing involved there. But 6x squared, is it 6x times x, or is it 3x times 2x? Well, there's no way to tell just by looking at it right away. So what you have to do then, and that's why I say that these take warming up to, they take warming up to because you have to be in the mood for a puzzle. If you're in the mood for a puzzle, then it's like, great, settle down and get yourself a nice little Sudoku type puzzle. Settle down and say, okay, here we go. We're going to maybe think of this as 6x times x, and we're just going to see if it works. And if it doesn't work, we'll have to cross this off and try that. That's if it doesn't work. First, let's see if it works. Okay, we're a little bit lucky because negative 2 has to break up as, well, it has to break up as either 1 times 2 or 2 times 1, really. So if I go 1 times 2, then my outer product is a 12x, my inner product is a 1x, and is my 12 and 1 going to combine to give me a negative 1? No way in the world, right? So that didn't work. The 1 times the 2, hey you, come on you. The 1 and the 2 did not work. So I'm going to try the 2 and the 1 now. My outer product will be a 6x. My inner product will be a 2x. Is there any way I can get a 6 and a 2 to combine to a negative 1? By adding, by subtracting? No, it's not going to work. That didn't work either. So what that really means is that 6x times x doesn't work. Start over. Now we're going to have to try, start over. Now we're going to have to try the 3x times the 2x. And hopefully something will work. If nothing works, you'll just say, hey, nothing works. It's a prime trinomial that cannot be factored. You can't do it. Don't do it. But we're hoping it'll work. So again, the 2 has to be either a 1 times 2 or a 2 times 1. So maybe I'll try the 1 and the 2 this way first. And let's see what we got here. We'd have a 6x here on the outside product. We'd have a 2x on the inside product. Can I get the 6 and the 2 to give me a negative 1? And the answer is nope. Nope. That ain't going to work. That ain't going to work. That ain't going to work. And so the only other thing to try is to put the 2 here and the 1 here. And if this doesn't work, we're going to give up. We will give up if it doesn't work, but we have to try it. So 3x times 1 is 3x. 2 times 2x is 4x. Can I combine a 3x and a 4x to get this in the middle, a negative 1x? And I can. How do you do that? You make this a negative 4 adding a plus 3. Negative 4 plus 3 will give me negative 1. Cool. So if this is plus, that means this is plus. And if this is minus, it means this is minus. And spot check again. A negative 2 times a positive 1 would be a negative 2. So it is working like a charm. Whoops, put your negative back in there. There we go. It worked! Yay! So these take warming up too because, well, sometimes you have to try more than one way for the first term. Oh, there's that 6x squared again. Maybe it'll be 6x times x. Maybe it'll be 3x times 2x. I don't know. 6x times x didn't work last time, so hopefully it'll work this time. Let's see now here. I have to break up. Oops, I have to break up the 2 as either a 1 times 2 or a 2 times 1. So, let's try this. All right, is this going to work? Outside, 6x times 2 is 12x. Inside, 1 times x is x. Does a 12x and an x give me an 11x? Well, it can if I do it this way. Plus 12x minus 1x would give me plus 11x. I'm glad I tried the 6x times the x. See, now I'm happy. Okay, so let's see. If I want a plus 12x, I have to multiply the 6x times a plus 2. And if I want a minus 1x, I have to multiply a minus 1 times x. And again, let's just make sure that by making this a minus 1 and this a plus 2, do we still get the do we get what we need? Yes, we do. Minus 1 times plus 2 is minus 2. So it's working just great. Just great. Boy, that was quicker than I wanted, or than I thought it would be. Okay, this one. Oh, you should try this one yourself. You should pause the video for sure. You should pause the video, try it yourself, and then come back. If you're coming back for a hint, here's the first hint. 8x squared. Is it going to be 8x times x? Is it going to be 4x times 2x? We don't know. You just have to try. You try one, and if it doesn't work, you try the other. So usually I like to start with the less extreme things. And if I see some really big numbers in here, like 100 or something, then I'll start with the extremes. But if the numbers I'm seeing are like not too incredibly gosh darn big, then it's usually you want to start with sort of the nice numbers, the 4x and the 2x. They're not so extreme. They're close to each other, right? Not an 8x times a 1x. That's weird. So anyway, I don't know if it's going to work. I'm just trying it. So I got a 1 and a 15, or a 3 times a 5 to make a 15, or of course, could switch them around and do them the other way. So a maximum of 4 ways to try the 4x times the 2x. Let's see now here. I'm trying to get a 26. Now after a while, you can start trying to do this in your head a little bit. You know, instead of always using ink or pencil and writing it out every single time, you might be able to just kind of see things after a while. That's what you hope to get to, is a point like that after some practice. But notice this is going to work pretty good. This is going to work really well. To have a 4x times a 5 is a 20x on the outside, and a 3 times 2 is a 6x on the inside. Notice I got a 20 and a 6, and it's going to be pretty easy to make a negative 26 out of that. Again, it's always by adding, but in this case I'm going to add a negative 20 and a negative 6. Negative 20x, negative 6x gives me the negative 26x that I want. So since these both have to come out negative, these both have to be negative, and we'll just double check real quick. If I use a minus 3 times a minus 5, do I get a plus 15? And the answer is yes, I do, which means everything's working. So here's our answer right there. 4x minus 3, 2x minus 5. All right, here's another one. Last one. Again, I think it's a good idea for you to pause and try this one yourself, see what you can do. And if you get stuck, come back and see what I did. Okay. This one's really nasty. Well, I shouldn't say nasty, but it's really almost nasty. It could be nasty because the 12x squared could be 12x times x. We don't know. Could be 6x times 2x, maybe. Could be 4x times 3x. Look at this. These are the nasty ones. These are the ones that take some getting used to, because I'm going to have to try 12x times x, and if it doesn't work, I'll have to try 6x times 2x, and if it doesn't work, I'll have to try 4x times 3x. Right? So there's kind of a lot of guessing here. So I'm going to start, I'm not guaranteeing this will always work, but I'm going to start with the numbers in the middle, the 4x and the 3x, because often that'll do it for me. So I'm going to take the 12x squared and I'm going to think of it as a 4x times a 3x, and I'm going to hope this works. Now this 20 here, oops, that 20 could be, let's think about this, a 1 times a 20, a 2 times a 10, a 4 times a 5, or kind of go in the opposite direction like this, right? So that's 1, 2, 3, 4, 5, 6 things. 6 things to try over here. So this could take a little while because I've got 6 things to try in 3 different things. That's actually 18 different combinations that we have to check out. So if you're really unlucky, you might end up going through 18 combinations before you either find the answer or discover that there is no answer. Anyway, we're trying to get a -1 in the middle. So let's try some numbers in the middle here too. Let's try a 5 and a 4, and I just grabbed those kind of at random. I don't know what the answer is right now. So if I go 4x times 4, I will get a 16x. And if I go 5 times 3x, I will get a 15x. Here's the question. Can you add some kind of a positive or negative 16 to a positive or negative 15 to get a negative x? And we're getting lucky again here. Holy cow. Let's back up a few grays here. Okay, we're getting lucky because the way you can do that is to have a negative 16 with a plus 15. Negative 16 plus 15 will give you a negative 1x, just like that. So I know this is going to work for the inner and outer terms anyway. So to get a negative 16x, I would have to multiply this 4x times a negative 4. And to get a plus 15x here, I would have to multiply a positive 5 times a 3. Last but not least, make sure you double check. Does having a positive 5 and a negative 4 make this work? And so far it always has. By the way, if it didn't make it work, you just have to go back to the drawing board and start guessing other things. Sometimes it'll happen that you'll get something that you think is going to work, and then you check plus 5 times a minus 4 and you get the wrong thing. Like if that was a plus 20 instead of a minus 20, you'd say, dope. And you just keep trying until you did try every single possibility. And I think that's the end of our lecture. Oh, we can play Dotso again. Cool. I like Dotso. Sort of. Okay. So yeah, so I got to turn this off. I almost remember how to do that. Remember that you can leave questions down below. Boink. Boink. Yeah, you can leave questions down below there, and I will get to them. I'm checking in at least 4 days a week. And how do you turn this off again? I know it can be done. There.